Hello everyone, welcome to my video tutorial on Terraform for absolute beginners. This is a tutorial that I created for getting started with Terraform. I'll create an advanced Terraform course in next tutorial. So before I start my tutorial, I'm a blogger and I write my blog at techieandtravel.com. Do check it out. Also, if you like my YouTube contents, do like, share, subscribe and comment on it. So before we dive deep into Terraform, I want you to understand the overview that we are going to talk on today's tutorial. First, we are going to discuss about infrastructure as a code, and then we are going to discuss about Terraform and its core components. Then we are going to do installation of Terraform, and then I want you guys to learn about Visual Studio Code, which is a open source code editor. And we are going to talk about Terraform object types, and we're going to discuss the Terraform workflow. And finally, we are going to deploy a single web server in AWS with Terraform. So let's start with infrastructure as a code. So infrastructure as a code is a way of provisioning the infrastructure through code. It's basically defining, provisioning, and managing your entire infrastructure through code. So for instance, if you guys have been using AWS Management Console, you go into the Management Console by logging in with your root credential or as an IAM user, and then you use the Management Console to create the instances. So infrastructure as a code is defining all those steps that you do in the Management Console through code. So it automates the provisioning and deployment, and it is a method where you represent the entire infrastructure state in a file. It's stored in source control. So the cool thing about it is, for instance, in your management console, if you want to add an additional instance in EC2, you just log in and create an EC2 instance. But since infrastructure code is a method where you define all those infrastructure in a single file, you have to version control it. And additional advantage of ISC is its reusability. Once you define the infrastructure in a code, you can reuse the same code time and again. One important concept on infrastructure as a code is declarative approach versus imperative approach. So imperative approach is an approach where you define step-by-step instruction on what has to be done, and it is analogous to giving specific orders to achieve the final state. Whereas in declarative approach, it describes the desired end state of infrastructure. In declarative approach, you don't have any explicit steps definition, unlike in imperative approach. That is, in declarative approach, you define the desired end state of infrastructure you want, and it's the job of the tool that you use, in our case Terraform, and it's Terraform's job to get you that desired end state. And if it cannot get to the desired end state, then it will fail. Another important concept in infrastructure as code is idempotent and consistency. Consistency is basically each time you do something, your result should be same or your result should be consistent. But Terraform is idempotent in the sense that if you haven't changed anything in your code and you reapply it again in the same environment, then nothing is going to change. That means if you see here, suppose you have a code that defines provisioning of 3 VM. So once you run the code, it provisions 3 VMs. And if you reapply the code and if it still runs 3 VM, then it's non-idempotent. But in idempotent behavior, if you reapply the exact same configuration file without any change, then the second run is not going to create additional resources. Terraform is idempotent in the sense that if the code is not changed, then it's not gonna do anything even if you apply the exact same configuration file. Another important concept is push or pull method. So are you pushing or pulling the configuration to the target environment? Basically, in pull method, you have a situation where in target environment you have some agent running and it pulls the configuration from certain central source on a regular basis. But infrastructure as a code, or Terraform in general, is a push approach where you push the configuration file to the target environment. Now that we understood what infrastructure as code is, let's discuss about Terraform. So Terraform is an infrastructure automation tool, and it's an open source project that is managed by HashiCorp. There are paid versions of Terraform available as either Terraform Cloud or Terraform Enterprise, but in this specific tutorial we'll focus on the open source version. And it is also vendor agnostic, meaning that it does not prefer any particular cloud or service. You can use it with AWS, you can use it with Azure, you can use it with VMware, DigitalOcean, etc. Pretty much any infrastructure service that you are using in day-to-day life are supported by Terraform, and it's a single binary that is compiled from Go. So the core software for Terraform is a single binary file. It's a declarative syntax. So you are describing basically how you want the entire infrastructure or the end state of infrastructure to be, rather than an imperative approach where you define specific steps. So it's consistent and it's idempotent, as we discussed earlier. Actual configuration files are written in HCL or HashiCorp configuration language, which is a derivative of JSON, or in JSON directly. So it's a push-based deployment, as we talked earlier. So there is no agent to maintain. Let's talk about the core components. So the first core component is its executable, which is a single binary file that you invoke when you run Terraform. You have to make sure that the Terraform binaries are available in your path, which we'll see in a bit. And the second important core component is its configuration file. That is, the configuration you are going to deploy will be contained in one or more Terraform files, which typically has .tf extension. And when Terraform sees one or more Terraform files in a directory, then it will take those files and stitch them together into a configuration. Another important core component is its provider plugin. So these are executables that are invoked by Terraform to interact with the services API. For example, AWS would be considered a provider, and if Terraform wants to talk to AWS and provision resources, it utilizes the provider plugin to do so. So most common plugins are hosted in public Terraform registry at registry.terraform.io. And the other important component is its state data. That means once the resources has been created, then Terraform keeps track of what is going on. It maintains the state of the infrastructure in a state file. So it's basically a mapping of what you have defined in your configuration versus what exists in your target environment. Next, we'll talk about installing Terraform. So as I told earlier, it's a single downloadable executable file that is suitable for your platform, and then you just have to make sure that you add the path to your environment variable. Since I will be using Windows, I'll be showing you the installation procedure for Windows. Let's look at it. Here I'm in my Google page, and if I type download Terraform, it's gonna give me the first link, and I can click on AMD64 and download it. I already downloaded it and placed it in my downloads folder. Go ahead and extract it. I already extracted it, and if you enter, you can see a single binary file that we discussed earlier. You can either run it from the downloads folder, but I don't prefer to do that, and I like to place the executable binaries in C drive. So I copied it and went into C drive. I created this folder called bin and placed it in there. Once you add the binary to the appropriate folder, make sure to add path to the environment variable. So you can do that by clicking on the properties, and depending on the Windows that you have installed, then you click on advanced system setting and click on environment variables. So over there, you select the path and click on edit. In here, you can add or remove the path. Here you see that I already added the path for the Terraform executable that is in C drive bin folder. But if you have located it in some other folder, you can just click on new and add your path. So that's how easy it is to set up Terraform. Another thing that I want you to know about is Visual Code Studio. So I'll post the links for both Terraform download and Visual Code Studio download in the description section. But Visual Code Studio is my preferred code editor of choice, and you can use whatever makes you comfortable, but I specifically like this because I can look at the files and even work with the terminal, so I find it cool. So you just click on download for Windows and download it and install it as you install other specific Windows packages. So I already have it installed in my system. I can just open the Visual Studio Code, and if you are using it for the first time, then you can definitely create a new file or open a folder where you want your Terraform configuration files to sit in. So as I told earlier, this editor specifically provides the terminal as well. You can click on terminal and you can use the terminals like the normal PowerShell or like the normal command prompt, that you are used to using. So as I told earlier, my Terraform binary is placed under C drive bin folder. Let me go into that folder, and if I do ls or dir, whatever is comfortable for you, I can see my executable in here. Let's confirm by typing in Terraform, and you can verify that the Terraform is installed. So it provides the list of main commands and other sub commands that you can use with Terraform, which we are going to discuss in a bit. So this is how you can set up your workstation by installing Terraform in Windows. Next, we'll talk about the Terraform object types. When you are working with Terraform object types, there are three things that you need to know about. The first one is provider. So the provider block in your code specifically defines the information about the provider you want to use. For example, we are using AWS provider, and that provider wants to know about the account, and it wants to know about the region that you are going to be using. The next object type is resources. So resources are the things that you want to create in your target environment, like EC2 instance, like the virtual network or the database instance, etc. So each resource is also associated with the provider and will require some additional information in your configuration. The third one is data source, which are a way to query an information from provider. So you are not creating anything, you are just simply asking about the information that you may want to use in your config. So just like the resources, data source are also associated with the provider, and data source could be a current list of availability zones in a region, let's say, or it can be an AMI to use for your EC2 instance, etc. In this tutorial, we'll create a simple NGINX web server, and we'll create it in US East 1. We'll create a VPC with 10.0.0.0/16 as the CIDR block. We'll create a public subnet with an EC2 instance where we'll launch our NGINX web server. We'll create a security group for our EC2 instance, and we'll create an internet gateway for the EC2 web server to get out to the internet. And in order for the traffic to route to the internet, we'll create a route table and we'll associate it with the instance or the subnet. Here I'm in my AWS management console because before starting to work on the Terraform configuration, I want you guys to create an IAM user for the specific purpose of working with Terraform. For my case, I already created a Terraform user. I'll click on it. You guys can go ahead and create an IAM user. If you are unaware of how to create an IAM user, you can follow my tutorial on IAM, which is in my YouTube channel, and click on security credentials, and here I'll create an access key. So this access key ID and key I'll be using in the Terraform configuration file. So copy the key and key ID to somewhere safe because you are going to be using this in your configuration file. So you are not supposed to reveal this to anyone else other than yourself. So for my specific case, I'll delete it before I publish it into the YouTube channel. Once you create your IAM user, let's head back into the Visual Studio Code. For this specific tutorial, I'll be working on a code that I have already published in my GitHub. I'll post this link in the description as well. So there is a folder called TechieWeb, and I have a main.tf file that has all the instructions for creating a simple NGINX web server. We'll discuss about each and specific blocks of code that we have in here. So you can go ahead and download this configuration file in your local machine. For my case, I already downloaded it and placed it under Techie and Travel. So I'm going to copy this main.tf. .tf stands for Terraform. So all the Terraform files have .tf extension, and I'm going to copy this specific file and place it under C drive, and I created a folder called Terraform in here. This is because I just don't want to run the program or anything specific that I'm working on from the downloads folder. You can choose any folder of your choice in the Windows system. So I placed it under main.tf. Now I'm going to open the Visual Studio Code. So in here, I can go ahead and choose the terminal. You see that I'm already in the Terraform directory, but if you are using it for the first time, you can simply go ahead and open the folder and choose the Terraform or whatever folder you worked upon or whatever folder you copied your main.tf file earlier. So you just select the folder and you are in the Terraform folder in here. So first, let's understand the block syntax. So HashiCorp configuration language uses block syntax for everything in the file, and it's a simplified version of JSON that is easier to read, and it supports inline comments. So each block is going to start with a block type keyword, and this describes what type of object is being described in the block. So next is a series of labels that are dependent on what type of object we are working with, and the last label in series is usually a name label, which provides a way to refer back to the object in rest of the configuration. So for example, we are defining an AWS VPC resource, so it will look something like this, where we define the resource as a block type, and we are going to create a VPC, so we defined AWS VPC as a label, and we provided the name label of VPC. So within that block, we are going to have one or more key value pairs that makes use of available argument for the object type. So for example, something like this for VPC definition of a CIDR block with a value. So each key, which is a CIDR block, will be a string, and value can be of any different data from types that Terraform supports, which we'll talk about in a bit. And we can also have nested blocks inside the main block, which will be having more key value pairs. So for example, for EC2 instance, we can have something like definition of EBS volume with some size. So next, we are going to look at the complete definition of infrastructure for creating a single NGINX web server instance in our main code that we downloaded from GitHub. So let's look into that. As we discussed earlier, we have three object types, one being the provider block. In this specific case, you can see that we have a provider block, and we are using provider as the keyword to say that this is a provider object, and the type of provider that we selected is AWS, because we are going to be creating the NGINX web server in AWS. So this is the way that Terraform will know that we'll be using an AWS provider. So inside the block, we have a set of key value pairs. So you see we have three different specific keys, and each keys have certain values. So this access key and secret key are the keys for the IAM user we created earlier. So over here, we created and generated the access key and key ID. So that is what you have to place instead of the access key and secret key. So let me copy and paste the secret key that I downloaded earlier. Just make sure that you don't reveal this to anyone else, because this is highly critical. And for my specific case, I'm going to be deleting it before it is published. And the reason key has the value for US East 1, where we'll be deploying our code. So the next object type is data. And in the data section here, we have a single data source. So we use data keyword to specify that this is a data source. And data source type is AWS SSM parameter, and this is a service manager parameter that we are giving it a name level of AMI. So within the configuration block, we have a single argument name, and we are setting it equal to the path to the parameter. This particular parameter, it grabs the latest Amazon Linux to AMI ID for the region we are currently in, and we'll make use of this value later when we create our AWS instance. So scrolling down, we see another object type where we define the resource portion. We'll start with networking, and we are going to create an AWS VPC, and we start the block by specifying the resource keyword, which is followed by the resource type, in this case AWS VPC, and we are giving it a name label of VPC. So inside this configuration block, we have defined the CIDR block and the DNS hostname to be true. So looking at the next block, we are going to create an AWS Internet Gateway, and we want that Internet Gateway to associate with the VPC we just created. So to do that, inside the config block, we have a single argument block called VPC ID, and we are using the reference syntax to reference the ID of our VPC. So that is AWS VPC, because that is the name label that we provided earlier. So we have AWS VPC, and the ID is the attribute that we want from the resource. So AWS VPC that we defined in here, and VPC.id is the attribute that we want from the VPC. So don't get confused with all these definitions. If you want to know about the argument and attributes that are available for a resource, you have to look into the documentation for the provider and resource. I'll post the link for the documentation in the description section below. So scrolling down, we already created a VPC and we associated an internet gateway with the VPC. Now we'll define a subnet where we'll create our EC2 NGINX instance. We have a resource AWS subnet. We give a label of subnet 1 and we are assigning a CIDR block of 10.0.0.0/24 and associate with the VPC. Since we'll be creating a web server that we want to have a public IP, we'll set the map public IP on launch to be true. Next, we are creating the route table. So we are going to create an AWS route table called RTB, and we are going to associate it to our VPC that we defined earlier. And here is our first nested block. So in our nested block, we can specify the route to add to that route table. In this case, we are creating a default route which is pointing to the internet gateway. If you remember the description in the slide that I discussed earlier, for the traffic to pass out from the EC2 instance to the internet, it has to have a route definition in the route table. So the last portion of networking is to associate our route table with the single subnet. We'll do that by creating an AWS route table association called RTA subnet 1, and within that configuration block we are going to specify the subnet ID of our single subnet and then the route table ID that we just created, and now there is an association between those two objects. Next, we are going to create an AWS security group that allows port 80 from anywhere to talk to our EC2 instance, and we'll associate the security group with the VPC. So over here you can see that we have a resource for AWS security group. We gave it a name label of NGINX security group and we associated it with the VPC. This name label is the name for the security group that we create, and inside of that nested block we are setting the front port and to port to 80 and the CIDR block of 0.0.0.0, which means allow traffic from anywhere on port 80, and below that we have a egress block, and this egress nested block allows outbound traffic to everywhere. Lastly, we have to have a EC2 instance definition where we'll be running our NGINX instance. So we are creating a resource AWS instance type and we are giving it a name label NGINX1. For AMI ID, we are going to be referencing our data source. Here you see that syntax is a bit different from the regular resources that you defined earlier. We have to specify that it is a data source by saying data dot, the type of the data source, the name label, and the attribute that we want from the data source, which is value. And we specify the instance type to be T2 micro. We specify the subnet ID, that is we are attaching it to the subnet that we created earlier, and in the VPC, the security group that we created earlier. So this custom user data that we provided installs the NGINX server and replaces the default index.html file. Next, let's look at the Terraform workflow. So Terraform, as we know, it makes use of service provider plugins to interact with services like AWS. So first, it needs to get those provider. So this is done as part of the initialization process, which is done by executing Terraform init command. So Terraform init looks for the configuration file inside the current working directory and examines them to see if they need any provider plugin. If they need it, then it will try and download those plugins from the public Terraform registry unless you specify any alternate locations. Terraform will also need to store the state data about your configuration somewhere. So part of the initialization process is getting that state data back and ready. And once initialization is complete, Terraform is ready to deploy the infrastructure. So the next step in the workflow is to plan out your deployment with the Terraform plan. So in this case, Terraform will look at your current configuration and the contents of your state data and determine the difference between two and make a plan to update your target environment. So it will make a plan to update it to the target environment to match the desired configuration that you specified in the configuration file. So Terraform will print out the plan for you to look at so that you can verify the changes that Terraform wants to make. And this plan step is not absolutely necessary, but it is ideal to know what Terraform is planning to do before it actually does it, right? You can save the plan changes to any specific file and then feed it back to the Terraform in the next step, or you can just simply run Terraform plan and look at what actually Terraform will be making changes. So the final step is to actually make the final change. We do that so by using the Terraform apply command. So this Terraform apply is gonna make the change to the target environment to match what the Terraform plan showed earlier. So there is one more command that you can use called Terraform destroy, and this is specifically useful for guys using the free tier because you don't want your resources to be running once you are done working with the Terraform configuration, and you can run Terraform destroy to destroy everything in the environment. So next we are going to actually apply the configuration file we created earlier. Let's do that. So as we looked earlier in the Terraform workflow, the first step is to execute the initialize command. Before that, I want to make sure I'm in the right folder. So over here, I'm going to run Terraform to initialize the Terraform. As you see, Terraform is going through the process of initialization, and if it requires the plugin to be downloaded, it will go ahead and download it from the Terraform public registry. Now you can see that Terraform has successfully been initiated. So after the initialization, the next step is to execute the Terraform plan. So as discussed earlier in the Terraform workflow, it will print out the plan that is going to execute. So if you look into the Terraform plan, you will see that it is going to create the resources where it will create the NGINX resource that we defined earlier. It will create the internet gateway, and similarly all the resources that we defined. So I'm gonna execute Terraform apply, and it's gonna go through the series of process of applying the config, and it will ask or prompt me to validate that I'm actually trying to create the resources. I'll place in the parameter yes. So it will go through the series of process of creating VPC and the subnet and the EC2 instances, route tables, which we'll see in a bit. So as you see, it's undergoing the series of process to create the resources that we specified above in the main.tf file. One thing I want to specify is that this is not the correct way to define the resources where we provided all the key value in the same main.tf file. We have a systematic way to define the variables in a separate file, which we'll discuss in the advanced Terraform tutorial. And as you see, it successfully applied it. Now let's head back to the terminal. Make sure to select the correct zone where you specified in your terminal. I selected US East 1, and I'm going to refresh it now. As you see, it's loading the instance, and here it is. We specified a T2 micro, and we specified it to be the public subnet and have a public DNS. So let me copy this address and type in the browser. So the message that we provided in the index.html is printed: your first Terraform built web. Woohoo! Congratulations, you successfully built it. In the next series of tutorial, I'll be talking about the advanced setup with the Terraform. Stay tuned, and if you like my videos, please like, share, subscribe, and comment on it. I'll be covering further more videos in my upcoming tutorial. Thank you.